Part is nothing but the solubility analysis. Solubility analysis कि आपके कंपाउंड सोल्यूबल है या नहीं, किस में सोल्यूबल है, एक्वियस सॉल्वेंट में या फिर ऑयली सॉल्वेंट में, उसका सोल्यूबिलिटी कितना है. Solubility analysis is very important because more will be the compound water soluble, more will be the more will be the aqueous solubility, and it is easy to formulate. So if compound is lipid soluble, then it will have more bioavailability. So solubility analysis focus on the drug solvent system that occurs in the pre-formulation. Solubility that affect the bioavailability. क्योंकि अगर solubility कम है तो bioavailability भी क्या आएगा. Okay, so analysis of solubility involves determination of following things like HPLC analysis, UV analysis, gas chromatographic analysis, then fluorescence spectrum. So you can determine the solubility by using these three. Then again, solubility analysis involves the determination of pKa, dissociation constant. pKa means dissociation constant. Then pH, solubility profile, temperature dependency, और मतलब effect of temperature on solubility. Then dissolution, solubility product and solubilization mechanism. Solubilization mechanism. Under the solubility analysis, we have to study this: determination of dissociation constant, pH solubility profile, temperature dependence means effect of temperature on solubility. क्वेश्चन इसके ऊपर आता है 100%. डिसोल्यूशन, सॉलिबिलिटी प्रोडक्ट एंड सोल्यूलाइजेशन मैकेनिज्म, इसके ऊपर भी क्वेश्चन आता है. सोल्यूलाइजेशन मैकेनिज्म इंपॉर्टेंट है, को सॉल्वेंसी इंपॉर्टेंट है. उसके बाद में पीके डिटर्मिनेशन के मेथड्स कितने हैं वो इंपॉर्टेंट है. व्हाट इज द इफेक्ट ऑफ टेम्परेचर ऑन सोलिबिलिटी, वो एक इंपॉर्टेंट पार्ट है. तो इसके ऊपर क्वेश्चन आते ही आते हैं 100%, बहुत बार आ चुके हैं. सो फर्स्ट इज द डिटर्मिनेशन ऑफ dissociation constant. Okay, so pKa is nothing but the dissociation constant of drug. Dissociation constant of drug कि ड्रग सोलवेंट में कितना डिसोसिएट हो रहा है, कितना सोल्यूबलाइज हो रहा है. pKa is nothing but the dissociation constant of drug. Okay, now unionized lipid soluble drug which is absorbed faster. Okay, unionized form of drug is a lipid soluble in nature and therefore easily permeated through biological membrane. तो अनआयनाइज्ड ड्रग जो होता है, अनआयोनाइज्ड, वो उसका जो फॉर्म है अनआयोनाइज्ड फॉर्म, वो लिपिड सोल्यूबल होता है. आयोनाइज्ड फॉर्म जो है वो वाटर सोल्यूबल होता है. तो अनआयोनाइज्ड फॉर्म ऑफ ड्रग इज मोर लिपिड सोल्यूबल एंड इट इज इजीली परमिटेड थ्रू बायोलॉजिकल मेम्ब्रेन. ओके, and ionized form of drug is a less lipid soluble, it is a more water soluble and it is a less permeated through biological membrane. But if the drug is having less molecular weight, it is again permeated through aqueous pores. Ionized drug is not lipid soluble and therefore less permeated through biological membrane. Next one is now this pKa or dissociation constant is measured or it is determined by equation known as Henderson-Hasselbalch equation. Okay, इसके ऊपर क्वेश्चन आते हैं. So how pKa determination. So Henderson-Hasselbalch equation is used for measuring the dissociation constant. So what is it? For basic compounds, there is one formula: pH is equal to pKa plus ionized form of drug divided by unionized form of drug. For basic compound मतलब जो basic drug होते हैं उसके लिए formula है pH is equal to pKa plus ionized form of drug divided by unionized form of drug. और weak acid जो होते हैं उनके लिए भी same formula है, सिर्फ आयोनाइज को अनायोनाइज करो और अनायोनाइज को आयोनाइज करो. For weak acid or for acidic compound, pH is equal to pKa plus unionized form of drug divided by ionized form of drug. We have seen in the pharmacology also. Percentage ionization is a function of your pH and pKa of drug. Okay, so percentage ionization is equal to 10 raised to pH minus pKa divided by 1 plus 10 raised to pH minus pKa. Percentage ionization इसके ऊपर अपन ने फार्माकोलॉजी में देखा है pH minus pKa value. pKa is determined by different method like spectroscopic method, potentiometric method, titrimetric method, etc. You see this method in the detail in upcoming slide. So for weakly acidic drug, अगर कोई ड्रग वीक एसिड है तो उसका pH pKa कितना होता है, लेस देन 3. For weakly acidic drug, that means drug is having pKa dissociation constant less than 3. And for weakly basic drug, okay, and drug which are 8 to 9, basic drug will have pKa in range of 8 to 9. Weakly acidic drug will have pKa less than 3. Basic drug will have pKa 8 to 9. They are generally unionized throughout the GIT and they are absorbed throughout the GIT. This was again question in GPAT. Recently ये question पूछा है GPAT 2020 में. Weakly acidic drug having pKa in range of 1.5 to 3 and weekly basic drug which is having pK in range of 8 to 9. ऐसा पीके मतलब डिसीजन कांस्टेंट उन्होंने दिया था वहाँ पे रेंज में. सो एंड क्वेश्चन में बचा था कि वन ऑफ द फॉलोइंग सेंटेंसेस ट्रू रिगार्डिंग द वीकली एसिडिक एंड वीकली बेसिक ड्रग. सो दे विल रिमेन अनआयोनाइज्ड थ्रू आउट द जीआईटी, मतलब स्टमक में भी रहेंगे और आपके इंटेस्टाइन में भी रहेंगे. And they are absorbed throughout the GIT. Okay, we'll see it again. Don't worry. Now, pKa determination by UV. UV spectroscopy is also used as a tool for determination of this pKa. Dissociation constant of UV से भी measure कर सकते हो. Okay, spectral shift is detected. So more will be the ionizing or more will be the ionizing chromophore in the structure. It will shift absorption, spectral shift. It will shift absorption to a maximum wavelength. So that is nothing but the spectral shift. तो अभी इतना याद आपको pK determination by UV spectral shift are measured. ये नाइपर में आता है and it is a preferred method over potentiometry. Another method is nothing but the potentiometry, titrimetry. We'll see in the detail. So effect next one is the effect of temperature on solubility. ये भी डिटेल में आप लोग next slide में देखने वाले हैं. So if in general if there is a 10 degree change in the temperature, there is a 5-fold times change in the solubility. मतलब आपने अगर कोई कंपाउंड है नॉर्मल सोल्यूबलाइज करने का ट्राई किया है, वही कंपाउंड अगर सॉल्यूशन को 10 डिग्री का टेम्परेचर बढ़ा के ट्राई किया, 5 टाइम्स सोल्यूबिलिटी बढ़ता है उसमें. So if there is a 10 degrees change in the temperature, there is a 5-fold increase in the solubility. ये क्या याद रखो, इसके ऊपर भी क्वेश्चन आ चुका है. So मतलब ये पूरा इंपॉर्टेंट है, इसके ऊपर 4-5 क्वेश्चन आते रहते हैं. प्री-फॉर्मुलेशन. नाउ अगेन डिसोसिएशन कांस्टेंट क्या है? That is nothing but the pKa. Dissociation constant with pKa. So this Henderson-Hasselbalch equation is used to estimate the percent ionized or unionized. So remember, unionized form of drug is lipid soluble and they are better absorbed and they will have ionized. So unionized form of drug is lipid soluble and they are better absorbed than water soluble or ionized form. For weakly acidic drug, जो weak acidic drug होते, so pKa less than 8. pKa less than 8. Sorry, it is a weakly basic drug. Sorry, it is a weakly basic drug. I think maybe correction करना पड़ेगा ये. Actually, this was a mistake in Lachman itself. Lachman से ही as it is लिया है. Weakly acid, yes. Weakly acidic drug, if pKa is more than 8. For example, drug like phenytoin, ethosuximide, and weakly basic drug. जो वीक एसिडिक ड्रग है एंड वीकली बेसिक ड्रग है, pKa लेस देन 5. सो वीकली एसिडिक ड्रग will have pKa more than 8 and weak basic drug will have pKa less than 5. Weakly basic drug like theophylline and diazepam है. Okay, they will remain unionized throughout the GIT and completely absorbed. Weakly basic drug और weakly acidic drug ये थोड़ा सा याद रखो, इसके ऊपर क्वेश्चन आ चुका है. और एक बात बताऊँ मैं आपको. So weak acidic drug, which is weak acidic drug means what? They are having pKa more than 8. Weakly acidic drug means उनका dissociation constant जो है वो 8 से ज़्यादा होता है. So weakly acidic drug, so we having dissociation constant more than 8. For example, phenytoin, ethosuximide. Weakly basic drug having pKa less than 5, such as the diazepam and theophylline. So they remains unionized throughout the GIT and they are completely absorbed. Next one is a weakly acidic drug. Okay, weakly acidic drug. Those are having pKa in a range of 3 to 5. जो weakly acidic drug है जिनका pKa range 3 to 5 है, for example aspirin, ibuprofen, they are unionized in the gastric pH only. Okay, and they are absorbed from stomach only. But as they comes into neutral pH or basic medium, they gets ionized and they are poorly absorbed. So that's why aspirin जो है आपका वो weakly acidic drug है और वो क्या है acidic drug, weakly acidic drug है और वो उसका unionized, जैसे acidic pH में जाएगा तो वहाँ पे unionized फॉर्म में रहेगा तो वहाँ से उसका एब्सॉर्प्शन होगा. जैसे ही एस्पिरिन इंटेस्टाइन में जाएगा वहाँ पे न्यूट्रल pH या फिर बेसिक pH होगा तो वहाँ पे आयोनाइज हो जाएगा उसका आयोनाइजेशन and that will be poorly absorbed. So remember here, weakly acidic drug which is having pKa in range of 3 to 5, they are absorbed from the stomach itself. इसके ऊपर क्वेश्चन आ सकता. Now next one is weakly basic drug. So very weak basic drug which is having pKa in a range of 5 to 8. For example, morphine, chloroquine, they will remain unionized in the basic pH range. they will remain unionized in the stomach. They will remain unionized in the intestine. तो ये स्टमक से क्या होगा, स्टमक में इनका आयोनाइजेशन हो जाएगा, तो वहां से एब्सॉर्प्शन नहीं होगा. बट जैसे ही बेसिक पीएच में आएंगे morphine and chloroquine, because they are a very basic drug, they will remain unionized in the intestine, and from that part they will be absorbed. Strong acidic drug like bromelain and bromelain sodium, strong acidic drug like bromelain sodium, and strong basic drug like erythromycin, papaverine, etc. They are ionized in the stomach as well as intestine, and therefore they are very poor bioavailability. जो स्ट्रॉन्ग एसिडिक ड्रग होते हैं, जो स्ट्रॉन्ग बेसिक ड्रग होते हैं, वो क्या होता है, उनका आयोनाइजेशन होता है कहाँ पे, स्टमक में भी हो जाएगा और इंटेस्टाइन में भी हो जाएगा. दैट्स व्हाई दे हैव वेरी पुअर बायो अवेलेबिलिटी और पुअर एब्सॉर्प्शन. तो वीकली एसिडिक ड्रग है, वीकली बेसिक ड्रग है, वो कम्प्लीटली एब्सॉर्ब होता है. जो स्ट्रॉन्ग एसिड है, स्ट्रॉन्ग बेस है, वो कंप्लीट एब्सॉर्प्शन नहीं होगा उसका. ओके, व्हाट आर द डिफरेंट मेथड्स फॉर मेजर और व्हाट आर द डिफरेंट मेथड्स फॉर मेजरमेंट ऑफ पीके और डिसोसिएशन कांस्टेंट. Remember the methods. Okay, methods are very important यहाँ पे. So first method is a potentiometric method. So in this method pKa in a range of 3 to 10. Okay, that can be measured. अगर किसी का pKa 2 है तो वो इसमें नहीं आएगा, measure नहीं कर सकते. So in the potentiometric titration pKa range 3 to 10 can be measured. यहाँ पे एक ये भी आता है प्लॉट, इसका नाम ये प्लॉट, उसको सिर्फ याद रखो. ओके, यासुडा शेल्डोवेस्की प्लॉट इज रिलेटेड विद दिस डिटर्मिनेशन ऑफ पीके बाय पोटेंशियोमेट्रिक titration. इसका इतना याद रखो, यासुदा शेल्डोवेस्की, मुझे भी प्रोनाउंस नहीं करता है. नाउ ड्रॉबैक ऑफ दिस पोटेंशियोमेट्रिक titration is nothing but the precipitation. Alcohols like ethanol, methanol, propylene, propanol, okay, propanol, ethanol, methanol. These alcohols, then dimethyl sulfoxide (DMSO), then dimethyl formamide (DMER), and tetrahydrofuran, that is THF. They are the solvent used in the this kind of potentiometric titration. But most commonly methanol is used. Most commonly कौन use करते हैं, methanol. MEOH मतलब methanol. Methanol is used most commonly. So there are solvents like alcohol, like methanol, propanol, then dimethyl sulfoxide, then dimethyl formamide, then tetrahydrofuran. So these are the solvents used in the potentiometric titration while determining the pKa by potentiometry. But most commonly methanol is used. ये याद रखो. The next titrimetric method. Okay, in the titrimetric method for weak acidic drug versus standard base, the pH of half neutralization, जहाँ पे 50% न्यूट्रलाइजेशन होता है, pH ऑफ हाफ न्यूट्रलाइजेशन इज इक्वल टू pKa. ये भी याद रखो. pKa कहाँ पे आएगा आपका, जो हाफ न्यूट्रलाइजेशन pH है, जो pH ऑफ हाफ न्यूट्रलाइजेशन दैट इज इक्वल टू pKa. मतलब वही pH वही pKa है, जहाँ पे 50% न्यूट्रलाइज हो चुका है वहाँ पे ही आपका pKa है. फॉर वीक एसिडिक ड्रग वर्सेस स्टैंडर्ड बेस. Now UV spectroscopy is another method for measurement of your this pKa. So spectral shifts are measured. Spectral solubility measurement is also there. Okay, by another method is solubility measurement, which is done by HPLC. Capillary electrophoresis is also there. Foaming activity is also there. So these are the method for determination of pKa. Now next is a solubility. Okay. Now solubility terms, which are again very important. These terms, solubility terms, कि किसको वेरी सोल्यूबल बोलेंगे, किसको स्पेरिंगली सोल्यूबल बोलेंगे, किसको सोल्यूबल बोलेंगे, किसको प्रैक्टिकली इनसोल्यूबल बोलेंगे. नाउ यू कैन सी अ पार्ट ऑफ सॉल्वेंट रिक्वायर्ड टू डिसॉल्व 1 पार्ट ऑफ सोल्यूट. मान लीजिए कि आपके पास 1 मिलीग्राम सोल्यूट है, आपके पास कोई ड्रग है, तो उसको डिसॉल्व करने के लिए कितना सॉल्वेंट लगेगा, उसको 1 ml लगेगा, 2 ml लगेगा, 10 ml लगेगा, उसके ऊपर उसका सोल्यूबिलिटी जो है डिफाइन किया जाता है. सो द नंबर ऑफ पार्ट ऑफ सॉल्वेंट which is required to dissolve the 1 part of solute completely. Okay, and based upon that solute are classified whether it is soluble, sparingly soluble or insoluble, etc. So now let's see, if less than 1 part of solvent is required to dissolve 1 part of solute, it is known as a very soluble. If 1 to 10 parts of solvent is required to solubilize 1 part of solute, then it is known as a freely soluble. If 10 to 30 parts of solvent is required to dissolve 1 part of solute, it is known as soluble. Okay, इसके ऊपर भी क्वेश्चन आ चुका है. फ्रीली सोल्यूबल के ऊपर क्वेश्चन आ चुका है, वेरी सोल्यूबल के ये पूरा इंपॉर्टेंट है. नाउ इफ 30 to 100 parts of solvent is required to solubilize one part of solvent, then it is known as sparingly soluble. यहाँ पे देखो सॉल्वेंट क्या बढ़ते जा रहा है. पहले क्या था, सॉल्वेंट एक पार्ट है, तो 1:1 है, तो यू कैन से फ्रीली सोल्यूबल और वेरी सोल्यूबल. लेस देन 1 है तो वेरी सोल्यूबल, और 1 है तो सोल्यूबल मतलब फ्रीली सोल्यूबल है. So if 1 to 10 part of solvent is required to solubilize one part of solute is known as freely soluble. If 10 to 13 parts of solvent is required to solubilize one part of solute, it is known as soluble. If 30 to 100 parts of solvent is required to solubilize one part of solute, it is sparingly soluble. Again, if 100 to 1000 parts of solvent is required to solubilize only one part of solute, then it is known as a slightly soluble. So if 1000 to 10,000 parts of solvent is required to solubilize only one part, so it is known as a very slightly soluble. 10,000 plus parts of solvent is required to solubilize only one part of solvent, then it is known as practically insoluble. So you have to remember this. Again एक बार फिर से आपको रिवाइज करता हूँ यहाँ पे. रिवाइज मतलब वही बोलता हूँ. So number of parts of solvent required to dissolve completely one part of solvent. कितना सोलन लगेगा. मान लीजिए कि ये छोड़ो, पार्ट्स छोड़ो, मान लीजिए कि आपके पास 1 मिलीग्राम एक कोई पाउडर है या फिर ड्रग है, उसके लिए कितना ml सोलेंट लगेगा, ठीक है, डिसॉल्व करने के लिए कितना ml वाटर लगेगा. सो इफ 1 ml, इफ लेस देन 1 ml water is required to dissolve 1 milligram of powder, it is known as a very soluble. If 1 ml to 10 ml water is required to dissolve 1 milligram of powder, it is known as a freely soluble. If 10 ml to 30 ml of water is required to dissolve 1 mg of powder, it is known as soluble. If 10 to 100 ml of water is required to dissolve only 1 mg of powder, then it is known as a sparingly soluble. And if 10 to 1000 ml of water is required to solubilize 1 mg, it is slightly soluble. If it is 1000 to 10,000 ml of water is required to solubilize 1 mg, then it is known as a very slightly soluble. And if more than 10,000 ml is required, that is known as practically insoluble. ठीक है, इतना सिंपल है, आप कॉम्प्लिकेट मत करो. इसके ऊपर क्वेश्चन ऐसा आ चुका, मतलब बहुत टाइप क्वेश्चन होते हैं. डायरेक्ट क्वेश्चन आएगा, ऐसा भी डायरेक्ट क्वेश्चन आता है. इफ 10-30 parts of solvent is required to solubilize one part of solute completely, then it is known as, नीचे ऑप्शन देंगे आपको ये फ्रीली सोल्यूबल, स्पेरिंगली सोल्यूबल, सोल्यूबल, ऐसा. सो यहाँ पे याद रखो 10 to 30 मतलब सोल्यूबल, 10 to 30 मतलब सोल्यूबल, ठीक है. और उसके उससे कम है तो 10 to 1 फ्रीली सोल्यूबल, तो एक से कम है तो वेरी सोल्यूबल. बाकी प्रैक्टिकली इनसोल्यूबल ये वगैरह कुछ कभी पूछा नहीं है, ये तो नहीं कभी पूछा एग्जाम में, बट ये पूछा है. So what is solubilization? Solubilization means enhancing the solubility or increasing the solubility of poorly soluble compound by using different solvents known as a co-solvents. इसके ऊपर एक क्वेश्चन आ चुका है, कैसा आया था बोलता हूँ. Solubilization using co-solvent like ethanol, propylene glycol, glycerine. The solubility can be increased. The solubility of poorly soluble electrolyte, poorly soluble non-electrolyte. The solubility of poorly soluble non-electrolyte can be increased by using water-soluble solvent like propylene glycol, ethanol, and glycerine. Okay. Now this phenomenon is nothing but the phenomenon of increasing the solubility of weak electrolytes and non-polar molecule by addition of water-miscible solvent in which drug has a good solubility. It is known as a co-solvency. It is known as a co-solvency. The phenomenon is known as a co-solvency. And this was question again GPAT 21. So what is co-solvency? Increase of solubility of poorly soluble non-electrolyte and non-polar molecule or weak electrolyte or non-polar molecule by using water-miscible solvent like propylene glycol, ethanol or glycerine in which the compound has a better solubility. पहले क्या करो कि मान लीजिए कोई कंपाउंड है वाटर सोल्यूबल नहीं है, कम कम वाटर सोल्यूबिलिटी, लेकिन वो इथेनॉल में सोल्यूबल है. पहले क्या करो, इथेनॉल में सोल्यूबल उसको सोल्यूबलाइज करो और फिर वो सॉल्यूशन वाटर में डालो, तो ऑब्वियसली वाटर में भी डिसॉल्व हो जाए. दैट फिनोमेनन इज नोन एज अ को-सॉल्वेंसी. इसके ऊपर क्वेश्चन कम से कम 2-3 बार आ चुका है. नेक्स्ट वन इज यू कैन सी सॉल्वेंट एंड सॉल्वेंट स्ट्रेंथ. नाइपर में ये फेवरेट क्वेश्चन होता है. व्हाट इज सॉल्वेंट स्ट्रेंथ ऑफ डीएमएफ? कम से कम 2-3 बार पूछा है. नाउ फॉर एग्जांपल glycerol has a solvent strength of 0.5. Then ethylene glycol has a solvent strength of 1. Ethanol has a solvent strength of 1.5. dimethyl formamide and dimethyl formamide, and this has a solvent strength 4 because it is a highly polar. Dimethyl formamide and dimethyl acetamide. So it has a solvent strength of 4, highly polar. Okay, ये कभी कभी पूछ लेता है नाइपर में. Co-solvency is important for GPAT Niper as well as. Now solubilization and co-solvency again. Solubilization of poorly soluble non-electrolyte can be improved with suitable co-solvent like ethanol, propylene glycol, and glycerin. The phenomenon is known as a co-solvency. Mechanism by which co-solvent increases the solubility is nothing but they disrupt the hydrophobic interaction of the water. ये मैकेनिज्म कभी कभी एक आध बार, अभी ये नया है थोड़ा सा मैकेनिज्म बोल रहा हूँ आपको, ये दिस ईयर में भी दे में आस्क व्हाट इज द मैकेनिज्म, हाउ को सॉल्वेंट इंक्रीजेस द solubility of poorly water soluble drug. So co-solvent, what they do, they disturb the hydrophobic interaction of water with the non-polar solute at solute water interface, and that's how they increase the solubility. तो वो क्या करेंगे, जो solute water interface है उसके उसमें जो हाइड्रोफोबिक इंटरेक्शन है वो कम करेंगे, दे डिस्टर्ब करेंगे उसको. सो मैकेनिज्म बाय व्हिच को-सॉल्वेंट इंक्रीजेस द सॉल्युबिलिटी, इट इज बाय डिस्टर्बिंग द हाइड्रोफोबिक इंटरेक्शन ऑफ वाटर एट अ नॉन पोलर सोल्यूट एंड वाटर इंटरफेस. ये याद रखो, मे बी इट इज अ प्रॉब्लम क्वेश्चन फॉर नेक्स्ट. इफिशियंसी ऑफ को-सॉल्वेंट. Okay, efficiency of co-solvent for increasing the solubility depends on the chemical nature of your drug. कि आपके ड्रग का केमिकल नेचर क्या है उसके ऊपर ही इफिशियंसी डिपेंड होता है. इफिशियंसी ऑफ को-सॉल्वेंट टू इंक्रीज द solubility depends on the chemical nature of your drug. More will be the non-polar solute molecule, more will be the solubilization. जितना ज़्यादा नॉन पोलर होगा उतना solubility उसका बढ़ेगा by using co-solvent. Now, for example, hydrocortisone and hydrocortisone 21 heptanoid. Aqueous solubility is increased by propylene glycol as a co-solvent. Example there. Hydrocortisone is a hydrophobic. Okay, hydrocortisone 21 heptanoid is also hydrophobic. उसका solubility बढ़ाता है propylene glycol. Propylene glycol को नहीं यहाँ पे co-solvent. Okay. Now effect of temperature on solubility. What is delta H? Delta H is nothing but the heat of solution. Delta H आपको दिख नहीं रहा तो. Delta H is known as a heat. Delta H is known as a heat of solution, and it is nothing but the heat released or absorbed when 1 mole of solute is dissolved in the large quantity of solvent. So delta H or heat of solution is nothing but the heat released or absorbed when 1 mole of solute is dissolved in the large quantity of solvent. And mostly the process is endothermic in nature. Most of the time क्या होता है कि जैसे सोल्यूट कोई डिजोल्व होता है सॉल्वेंट में तो वो क्या करता है, हीट एब्सॉर्ब कर लेता है, आपको कूलिंग सेशन होता है. सो मोस्ट ऑफ द टाइम इट इज एंडोथर्मिक. सोल्युबिलिटी इंक्रीज विद इंक्रीज इन द टेम्परेचर. सो इफ ऐसे एंडोथर्मिक रिएक्शन है उसमें तो सोल्युबिलिटी इज इंक्रीज्ड विद इंक्रीज इन टेम्परेचर. ओके, बट देयर आर सर्टेन सोल्यूट लाइक लिथियम क्लोराइड and other hydrochloride salts. What happens with them? So when you try to dissolve this into water, there is a ionization. Okay, ionization of those compounds on dissociation, and they have negative heat of solution. And in such compound, increase in the temperature will decrease the solubility. तो इसमें क्या है कि टेम्परेचर का solubility के ऊपर क्या इफेक्ट है. मैंने जैसे बोला 10 डिग्री टेम्परेचर इंक्रीज करेंगे तो 5 टाइम्स solubility इंक्रीज होता है. लेकिन ये तो कॉमन है. उसके बाद में डिपेंडिंग अपॉन द कंपाउंड, ठीक है, इफ the reaction is endothermic, that means heat of solution is positive. At that time such compounds, on increasing the temperature, solubility is increased. But so there are certain solutes or compound like lithium chloride salt and lithium hydrochloride and other salts, when they dissolve in the water they get ionized, and the reaction is exothermic, they will release the heat, and that is the heat of solution is negative, and increase in the temperature will decrease the solubility of. Now delta H is obtained by solubility curve. तो कैसे करेंगे ये, इसका heat of solution कैसे डिटरमाइन करेंगे. तो heat of solution is obtained from solubility curves. You have to make a saturated solution, okay, at a controlled temperature. You have to make a saturated solution at a controlled temperature like 5 degrees Celsius, 25, 30, 37 and 50 degrees Celsius. And you can calculate the heat of solution by using equation delta HS मतलब minus delta H is मतलब heat of solution divided by R into 1 divided by T plus C. So R is nothing but the molar solubility, S is nothing but the molar solubility, T is the temperature in Kelvin, R is the gas constant, C is the concentration. So normally what happens, delta H means heat of solution is in a range of 4 to 8 calorie per kilocal per mole. So unionized the weak acids and weak bases. So if you try to dissolve non-electrolyte unionize the weak acid and weak bases. So at that time, delta H, that is heat of solution, is in a range of 4 to 8 kilocal per mole. Salt form of drug. Okay, salt form of drug is sensitive to temperature. Salt form of drug, okay, is again sensitive to temperature change, and it will have heat of solution in range of -2 to +2 kilocal per mole. Next is the partition coefficient. So what is it? It is nothing but the rate and extent of absorption of drug is affected by partition coefficient, and is again a measurement for lipophilicy of drug. ये ड्रग कितना लिपोफिलिक है, कितना वाटर मतलब हाइड्रोफिलिक है, वो कौन डिसाइड करेगा? पार्टीशन कोएफिशिएंट. पार्टीशन कोएफिशिएंट इज इक्वल टू concentration of drug in the organic phase or organic layer divided by concentration of drug in the aqueous layer. तो ये partition coefficient का फॉर्मूला है. Partition coefficient is equal to concentration of drug in the organic layer, concentration of drug in the aqueous layer divided by concentration of drug in the organic layer divided by concentration of drug in the aqueous layer. That is will give partition coefficient. So it is denoted by log P. Log P. Okay. So partition coefficient or this, okay, or log P, it is nothing but the measurement of drug lipophilicity. कितना lipophilic drug है. Okay. Oil water partition coefficient, that is nothing but the ratio of unionized drug in distributed between organic and aqueous phase at an equilibrium. That is a partition coefficient. Now it is nothing but the logarithmic scale. If your drug is having log partition coefficient 0, if any compound is having log P 0, that means compound has equal solubility in the organic as well as aqueous. Okay, so it has equal solubility. So अगर किसी compound का partition coefficient 0 है, उसका मतलब ये होता है कि that compound has equal solubility in the water as well as the solvent, partitioning solvent. अगर किसी compound का this partition coefficient, if log P is -2, that means compound is 100 times more soluble in the water. That is a compound is hydrophilic. If log P is equal to 5, that means compound is 10. Okay, that means compound is 1 lakh times more soluble in the organic solvent or partitioning solvent. So ये थोड़ा सा नया है. Actually, I have make these points recently. That's why it is not also present in the book. So you must try to write down or whatever you want to do. Now for the determination of this partition coefficient, octanol water system is the system which is most commonly used for the measurement of partition coefficient. Octanol water system is used for the determination of partition coefficient, and it is widely used method for determination of lipophilicity of drug. Okay. Then shake flask method. Shake flask method is also most commonly method used for determination of partition as well as distribution coefficient. Now Lipinski and its co-worker has given a rule of 5. A drug candidate should have those drugs which are having poor oral absorption and bioavailability. कोई ड्रग, जो ड्रग है पुअर बायोअवेलेबल है, उसके कुछ ये है, उसमें कुछ केमिकल कुछ पॉइंट्स होंगे उस ड्रग में, तभी वो पुअर एब्सॉर्प्शन है उसका. सो द ड्रग विल हैव पुअर oral absorption or permeability if exceeds one of the following values. तो लिपिंस्की ने क्या किया, एक कुछ 5 पॉइंट्स आइडेंटिफाई किए. तो लिपिंस्की हैज आइडेंटिफाइड दिस 5 points and he said that if drug candidate having more than any value more than following points, the drug will be poorly absorbed from the oral. Okay, so if drug is having this, if drug is having log P value more than 5.2, if drug candidate is having log P value more than 5, if drug is having molecular weight greater than 500 dalton, if drug is having more than 5 hydrogen bond donors in the form of either ammonia or hydroxide, and if the drug is having more than 10 hydrogen bond acceptors like nitrogen and oxygen, then this drug will have less oral bioavailability. एक जनरल assumption है कि लिपिंस्की ने क्या किया कि कुछ पॉइंट्स निकाले, तो उन्होंने स्टडी किया कि क्यों ड्रग पुअरली एब्सॉर्ब होता है. why there is a less oral bioavailability of drug, and he noted that certain points. These are nothing but the rule of five. He named that points known as the rule of five, Lipinski rule of five. They can ask you question on this. Lipinski rule of five is related with one of the following. They will give you absorption. They will give you the options like oral absorption, intravenous absorption, or intramuscular absorption, or anything. So it is related with the oral bioavailability or oral absorption. So if drug is having partition coefficient more than 5, if drug is having molecular weight more than 500 Dalton, if drug is having more hydrogen bond donors, drug is having 10 hydrogen bond acceptors, then that drug will be have less oral bioavailability. इसमें कोई भी ज़्यादा है, मतलब किसी ड्रग का अगर log p वैल्यू 6 है तो वो बहुत कम एब्सॉर्ब होगा, किसी ड्रग का मोलिकुलर वेट 600 डेल्टन है तो वो भी कम एब्सॉर्ब होगा, और किसी ड्रग में 5 हाइड्रोजन बॉन्ड डोनर्स है तो वो भी कम एब्सॉर्ब होगा. तो ऐसा, these are the rules of 5. Lipinski rule of 5. Now dissolution means what? Dissolution means the property of drug to undergo into solution. So that is nothing but dissolution. Dissolution means a drug goes into the solution. One of the control and several physicochemical properties. Dissolution is very important for it is a controlled and severe. It is controlled by different processes. Like it is based upon the chemical form of drug, then crystal habit, then particle size, surface area, solubility, weighting property of that drug. So dissolution of drug depends on the different physicochemical properties again. That is a chemical form, crystal habit, particle size, surface area, solubility, weighting property. Dissolution rate is nothing but the dissolution rate in which surface area of tablet remains constant during the dissolution, and that is known as a constant dissolution rate, and it is given by Noisy-Whitney equation. That is a dc upon dt change in the concentration per unit time is equal to dah, okay, into cs minus c. तो आपको यहाँ पे Noisy-Whitney equation भी दिया है. So dc upon dt change in the drug concentration per unit time is directly is equal to d into a cs minus c divided by h. Now we'll see individual terms. What is meant by dc upon dt? dc means rate of dissolution of particle. D means diffusion coefficient of drug in a solution in the GIT fluid. Then A is nothing but the diffusion constant for drug particle in contact with the GIT fluid, and H is nothing but the thickness of layer around the drug particle. CS is nothing but the saturation solubility of the solution in the diffusion layer, and C is nothing but the concentration of drug in the GIT. So that is how constant dissolution surface area. Okay, if the dissolution rate in which the surface area, okay, surface area of dosage remains constant in the dissolution, and is given by this Noisy-Whitney equation. तो आप सिंपल याद रखो कि डिसोल्यूशन का जो इक्वेशन है दैट इज Noisy-Whitney इक्वेशन. नाउ यू कैन सी, अगर यहाँ पे सोलिबिलिटी का टर्म्स दिया है, सोलिबिलिटी टर्म्स, ओके, डिस्क्रिप्शन क्या है वो वेरी सोल्यूबल किसको कहेंगे, इफ लेस देन 1 पार्ट ऑफ सॉल्वेंट इज इक्वल टू डिसॉल्व 1 पार्ट ऑफ सॉल्वेंट. फ्रीली सोल्यूबल कौन है, इफ 1 to 10 part of solvent is equal to dissolve 1 part of solvent. If 10 to 30 part of solvent is equal to dissolve 1 part of solvent is known as soluble. Okay, then again sparingly soluble किसको बोलेंगे, if 10 to 100 parts of solvent is equal to dissolve 1 part of solvent. 100 to 1000 parts are required, parts of solvent is equal to dissolve 1 part of solvent is known as slightly soluble. More than 1000 parts are required, it is known as a practically insoluble. Now Wood's apparatus is known as a constant dissolution surface area apparatus. For the determination of constant, क्यों करना है ये constant dissolution, ये बोलेंगे क्या चल रहा है हमको समझना है. देखो क्या होता है कि डिसोल्यूशन टेस्ट में क्या होता है, मान लीजिए कि आपके टैबलेट में कुछ पॉलीमर है, जैसे डिलेड रिलीज पॉलीमर, तो वो क्या करेगा, डिसोल्यूशन मीडियम में जाने के बाद वो एक्सेप्ट कर लेगा वाटर और वो सरफेस के ऊपर आ जाएगा. ठीक है, तो सरफेस के ऊपर आ जाएगा तो वहाँ पे एक ही साइड, जैसे टैबलेट आपके बाउल में है, डिसोल्यूशन बाउल में, डिसोल्यूशन वेसल में, तो उसका एक ही सरफेस दिख रहा है आपके सॉल्वेंट, बाकी सरफेस तो नीचे है. सो डिसोल्यूशन में भी अफेक्टेड, डिसोल्यूशन वैल्यूज में भी अफेक्टेड. दैट्स व्हाई कांस्टेंट डिसोल्यूशन सरफेस एरिया एप्रेस, मतलब टैबलेट को हर तरफ से सॉल्वेंट का इंटरेक्शन होगा. ओके, so Wood's apparatus constant dissolution surface area apparatus known as a rotating disc apparatus for a dissolution with constant surface area. इसके ऊपर GPAT में नाइपर में क्वेश्चन आता है. Okay, there are two apparatus First one is the rotating disc apparatus and static disc apparatus. Both apparatus are known as a apparatus used for dissolution having constant surface area. So याद रखो woods apparatus. Okay, ये कैसे देखना था. So this one is known as a static disc apparatus. Oh sorry, this is known as a rotating disc apparatus. Another one is the known as a static disc apparatus. Intrinsic dissolution rate means what? Dissolution rate milligram per minute per centimeter square is known as the intrinsic dissolution rate. The rate of dissolution of pure API, मतलब आपके उसमें कोई फॉर्मुलेशन नहीं बनाया, सिर्फ आपके पास पैरासिटामोल का पाउडर है. Dissolution rate of that pure paracetamol when parameters like surface area, temperature, agitation, stirring, pH, ionic strength kept constant. So the rate of dissolution is known as the intrinsic dissolution rate. ठीक है. बाकी जो पैरामीटर है वो कांस्टेंट रखो, सरफेस एरिया, उसके बाद में टेम्परेचर, बॉयल का टेम्परेचर, वॉल्यूम ऑफ डिसोल्यूशन मीडियम, पीएच, आयनिक स्ट्रेंथ, स्पीड, तो वो कांस्टेंट है. एंड डिसोल्यूशन करें आप प्योर पैरासिटामोल का, मतलब प्योर एपीआई का, सो दैट इज नोन एज इंट्रिंसिक डिसोल्यूशन रेट. इसके ऊपर भी क्वेश्चन आता है. नाउ इट अलाउज द स्क्रीनिंग under various physiological conditions. It allows the dissolution under various physiological. Now, intrinsic dissolution rate should be dependent on the boundary of thickness and volume of solvent. ये थोड़ा सा DCS divided by H is known as the hydrodynamic condition. ये पूरा पढ़ना पड़ेगा तभी समझ में आएगा. ठीक है. DCS divided by H is known as a hydrodynamic condition. So ये equation भी है उसका. Ionic strength of isotonic 0.9% sodium chloride is nothing but the 0.15. तो इसका भी पूछ लेता है कभी कभी, what is the ionic strength of isotonic sodium chloride? Ionic strength of isotonic sodium chloride, that is a 0.15. Isotonic, okay. So ionic strength of 0.9% weight by volume solution of sodium chloride is nothing but the 0.15. कभी कभी इसका पूछना आता है. Dielectric constant of water, नाइपर में 2-3 बार पूछा है. What is the dielectric constant of water? That is 80. Dielectric constant of water is 80. नाइपर में 2 बार पूछा, 2-3 बार पूछा. Now next one is a Maillard reaction. So it is actually incompatibility between your drug and excipient. जो ड्रग यूज कर रहे हैं आप और जो एक्सिपिएंट यूज कर रहे हैं उसमें अगर इनकॉम्पेटिबिलिटी है तो ये ऐसे कुछ रिएक्शन आ जाएंगे. सो व्हाट इज Maillard reaction? When a hydrous lactose is combined with the amine containing drug. अगर कोई amine containing drug है आपका और उसके साथ में डाइल्यूट आप यूज कर रहे हो हाइड्रस लैक्टोज, तो वो क्या होगा, वो हाइड्रस लैक्टोज विल रिएक्ट विद द अमाइन कंटेनिंग ड्रग, विल फॉर्म ए प्रोडक्ट नोन एज अ फुरफुराल्डिहाइड. ठीक है. सो इट विल फॉर्म अ फुरफुराल्डिहाइड एंड दैट कंपाउंड इज अ ब्राउन कलर एंड इट कॉजेस ब्राउनिंग ऑफ टैबलेट. जैसे मान लीजिए कि आपका व्हाइट टैबलेट है, इनिशियली तो वो व्हाइट ही रहेगा, लेकिन depending on the time span and depending on the rate of this reaction, so the surface of tablet will become brown, and that is known as the browning reaction or Maillard reaction. Hydrous lactose will react with the amine containing drug and it will form a brown colored product, okay, and it will cause browning of tablet surface known as a Maillard reaction. The product form is having bond like CONH bond, and that's why sometimes you can call a reaction product of Maillard reaction is nothing but the peptide. So surface color measurement of tablet is done by diffused reflectance spectroscopy. बाद में जब tablet आएगा तब भी बोलूँगा. So remember, surface color measurement of tablet is done by diffused reflectance spectroscopy. Tristimulus reflectance spectroscopy. Reducing sugar readily reacts with the primary amine and some amino acids, and they gives Maillard reaction. So drugs with a 10 or 20 amine function group or amine group gives brown color, also known as a browning reaction or Maillard reaction. So those drugs which are having amine function, if they are combined with the hydrous lactose, you will get a brown colored product, furfural aldehyde. That is nothing but the Maillard reaction. Okay, ये Maillard reaction होता है. Now this hydrous lactose only gives Maillard reaction. Okay, अनहाइड्रस लैक्टोज जो होता है वो Maillard reaction नहीं देगा. So just replace hydrous lactose with anhydrous lactose. So remember, they can ask you Maillard reaction is given by one of the following diluent. अगर आप ऑप्शन में दिया hydrous lactose, anhydrous lactose और place diet lactose ऐसा कुछ देंगे. So hydrous lactose it gives the Maillard reaction. Remember. नाइपर में बहुत बार पूछते हैं ड्रग्स सच एज एम्फेटामाइन आइसोनियाजाइड डेक्सामेथामाइन नॉरएपिनेफ्रिन लैक्टोज डिग्रेडेशन प्रोडक्ट इज नथिंग बट द 5 हाइड्रोक्सीमेथाइल प्रोपोल तो ये जो ड्रग्स है लाइक एम्फेटामाइन आइसोनियाजाइड नॉरएपिनेफ्रिन ये ड्रग्स if you combine this drug with the lactose hydrous lactose it will form a one degradation product known as a hydroxymethyl alcohol and that will cause brown color on the tablet surface known as the browning reaction or Maillard reaction इसका नाम क्या है Maillard reaction और browning reaction ठीक है दो नाम है now stability last part of your lecture stability क्या है stability means whether your drug is stable in the various condition or not okay that analysis is nothing but the stability analysis stability indication assay is nothing but the HPLC assay now stability is done by using three type so solid state stability is there then solution stability is also analyzed that is nothing but the effect of pH effect of ionic strength co-solvent temperature okay, light temperature and oxygen so effect of light temperature oxygen pH so that is nothing but that will affect whether your compound is stable or not that is being checked in the stability study. Stability of solution is done by using probing experiment at extreme pH condition. मतलब क्या है कि आपका प्रोडक्ट कितना स्टेबल है मतलब आपका ड्रग कितना स्टेबल है तो एक क्या क्या करो उसका पीएच कंडीशन मतलब ड्रग आपका 1 pH 2 pH 3 pH ऐसा उसके ऊपर रखो तो डिग्रेडेशन कितना होता है वो चेक करो stability of solution is done by probing experiment at extreme pH condition like 0.1 normal HCl water 0.1 normal NaOH Hasselbalch equation is used for this now stability analysis is done so it is very important again for pre-formulation and product development you have to find the stability and shelf life of drug major routes of drug degradation that is nothing but the mostly drug is degraded by oxidation hydrolysis and photochemical reaction so hydrolysis are of two type ester hydrolysis so those drugs which are having ester in their structure like okay so जैसे barbiturate vitamins antibiotics ये जो है anesthetic drugs local anesthetics वगैरह so they are the esters so they undergo ester hydrolysis and they will the hydrolysis product is nothing but the acid and alcohol amide hydrolysis means those compounds which are having amide function like example barbiturates phenethicillin then niacinamide chloramphenicol they will undergo again amide hydrolysis and will give you acid and amine इनका reaction product क्या है acid and then oxidation means oxidative decomposition of drugs like steroidal drug, vitamins, antibiotics, cytinidine. The most common form of oxidation is a auto-oxidation, which is a free radical chain process. Then again, photolysis means effect of light on the drug. Racemization means मान लीजिए कि आपने वहाँ पे एक लियो आइसोमर मतलब कोई भी अगर जैसे लियोमॉर्फिन इज मोर एक्टिव देन डेक्स्ट्रोमॉर्फिन so conversion of levomorphine into dextromorphine that will again affect the therapeutic value of that morphine. मान लीजिए कि सुडोइपेड्रिन जो है वो ज़्यादा एक्टिव है इपेड्रिन से सुडोइपेड्रिन क्या है ज़्यादा एक्टिव है तो सुडोइपेड्रिन का कन्वर्जन इपेड्रिन में होता है अगर लाइट की वजह से या फिर टेम्परेचर की वजह से या फिर स्टोरेज कंडीशन की वजह से so that is nothing but the racemization. Again you can see here what is temperature condition again very important different temperature condition. Okay. So what is meant by cold temperature? If temperature is between 2 to 8 degrees Celsius, it is a cold temperature. What is cool temperature? Cool temperature is between temperature 8 to 25 degrees Celsius. Room temperature कितना है 35 degrees Celsius. Warm temperature means what? 25 to 40 degrees Celsius. Hot temperature is more than 40. So you have to remember this temperature range. बहुत बार क्वेश्चन पूछा है GPAT में नाइपर में ड्रग इंस्पेक्टर फार्मासिस्ट में. Cool temperature is nothing but the 2 to 8 degrees Celsius. Cool means what? Cold means 2 to 8. Cool means 8 to 25, room means 35, warm temperature means 25 to 40, hot means more than 40. Now next point the polymorphic study or X-ray diffraction studies. X-ray diffraction, XRD. Okay, so this X-ray diffraction study is done for to know the crystal shape, to know the external surface of crystal. Okay, now in the again in the X-ray crystallography, sharp peak indicates the pure crystal. Okay, उसका एक इक्वेशन होता है n lambda is equal to 2d sin of theta and this equation is known as the Bragg's equation and this is the basis for X-ray diffraction. So n lambda is equal to 2d sin theta is known as the Bragg's equation. So this d is nothing but the distance between two crystal and theta is nothing but the angle of refraction. ठीक है। यहाँ पे देखो एक्सरे बीम एक्सरे का लाइट का बीम पास किए, यहाँ पे क्या है आपका पाउडर है। तो डिस्टेंस बिटवीन टू क्रिस्टल्स, दो क्रिस्टल, तो दिस एक्सरे बीम विल बी bombarded on powder will reflect that beam depending on the shape and surface of that powder. So 2D n lambda is equal to 2D sin theta, that is known as the Bragg's equation. D is nothing but the distance between two crystals. DSC means differential scanning calorimetry. Sharp peak it is used for determination of crystal purity again. Glass transition temperature. The temperature of polymer at which it gets converted to glasses, from glassy state to rubber state. तो polymer होता है आपके इंडस्ट्री में बहुत सारा polymer यूज करते हैं आप. So what is the glass transition temperature? नाइपर में ये क्वेश्चन पूछते हैं, जीपैट में पूछते हैं. Glass transition temperature or TG is equal to, it is nothing but the temperature of polymer at which it gets converted from glossy state to rubbery state. तो मान लीजिए कि यहाँ पे एक पॉलीमर है, उसको आपने हीट किया, ये हो गया उसका रबरी स्टेट और बाद में उसका ग्लासी स्टेट हो गया. टेम्परेचर at which polymer convert from glossy state to rubbery state is known as a glass transition temperature. So if you plot calories versus time and temperature, you will get such. यहाँ पे वो मेल्ट हो जाएगा, यहाँ पे वो क्रिस्टलाइज हो जाएगा. पॉलीमर जो है यहाँ पे क्रिस्टलाइज हो जाएगा ये टेम्परेचर पे, और ये यहाँ पे मेल्ट हो जाएगा. सो इनिशियली इफ यू ट्राई टू हीट द पॉलीमर, इनिशियली जैसे हीट कर रहे हो आप पॉलीमर का, सो इट विल नॉट चेंज, इसका कोई कंडीशन चेंज नहीं होगा पॉलीमर का. इट विल टेक सम हीट, initially it will not change, and at a certain temperature then it will be changed from one state to another state, and that temperature is known as a TG, glass transition temperature. Okay? So temperature at which polymer gets converted from glossy state to the rubbery state, that is the glass transition temperature. Question आ चुके हैं. Now what is meant by particle, what is meant by bulk density? Mass divided by volume. मान लीजिए आपने 5 ग्राम पाउडर लिया, कौन सा भी टाल का, और उसको वॉल्यूमेट्रिक सिलेंडर में लिया. अगर उसका वॉल्यूम आ गया 6 सेंटीमीटर, 5 डिवाइड बाय 6, दैट विल गिव यू बल्क डेंसिटी. अगर वही सिलेंडर आपने टैप किया 1 2 3 ऐसा मारा टेबल पे 10 टाइम्स 100 टाइम्स, so that will give you tapped density. So mass divided by tapped volume, that is a tapped density. Now compressibility index is equal to, compressibility index means Carr's index is equal to bulk volume minus true volume divided by bulk volume into 100. Hausner's ratio is nothing but the bulk volume divided by true volume. So you can see over here again. So if Carr's index of powder is between this 1 to 10, it is excellent flow. Carr's index is between 11 to 15, it is a good flow. If it is between 16 to 20, air flow. Possible 21 to 25. If it is between 26 to 30, it is poor flow. If Carr's index is between 30 to 37, very poor flow, and above 38, very poor flow. Hausner's ratio is also there. We have already seen this. Okay. Again, ये chart book में है already, so I'm not going to repeat it again. We have already seen angle of repose, Hausner's ratio, and Carr's index. Now incompatibility in the pharmaceuticals. Lactose जो है, lactose and hydrous lactose will give you Maillard reaction. Okay. And यहाँ पे एक याद रखो, Claisen-Schmidt condensation reaction. Claisen-Schmidt condensation reaction occurs while degradation of lactose and amine. Amine containing drug, when lactose is combined, so it will form a one product. Okay. 5-hydroxymethyl 2-purpuraldehyde. Okay. And conversion of this product or the lactose, जो free aldehyde group होता है lactose का, free aldehyde group of lactose will react with the amine function of amine containing drug, and it will undergo Claisen-Schmidt condensation reaction. ये याद रखो, क्वेश्चन आ सकता है, probable question. Then next one is a microcrystalline cellulose. Again it will also show Maillard reaction. It will absorb water, undergo hydrolysis. It will also cause absorption of certain basic drug. It is incompatible due to hydrogen bonding. Povidone and cross-povidone will also have some sort of incompatibility. They are prone to oxidation. The oxidation result in the peroxides, nucleophilic addition of amino acid and peptides. Then HPMC is also causes oxidation to the sensitive drug due to peroxides. colloidal silicon oxide, colloidal silicon dioxide will act as a Lewis acid and undergo under anhydrous condition and make drug causes adsorption of drug. In magnesium stearate, magnesium oxide impurity react with the certain drugs like ibuprofen and in the basic pH and provide the basic pH which can accelerate the hydrolytic degradation. And sodium starch glycolate is again a one adjuvant used in the tablet. So terminal aldehyde group of starch react with the hydrazine moiety causes hydrolysis of the drug absorption. It can react with the formaldehyde and decreases the function of disintegrate. Then again cross carbonyl sodium. So weakly basic drug absorb the sodium from salt. क्रॉस कार्मेलन सोडियम में जो सोडियम है वो वीकली बेसिक डोज जो है वो सोडियम का एब्सॉर्प्शन करते हैं और सॉल्ट फॉर्म करते हैं. दैट्स हाउ ड्रग एक्सिपिएंट इनकॉर्पोरेटेड. So this was today's